Good morning. First of all, as it was said, so LOSC is, you will hear this word LOSC a lot of time, is an acronym, so for LIGO Open Science Center, that probably was born in this way because LIGO started, but now that other observatory will join, probably in the next future it will change name. Probably will become Gravitational Wave Open Science Center. Anyway, this is the outline of the talk, so as you can see it will be very practical, so I will show you quickly again what is included in the data we deliver to the public, which are the available data set. Then I will talk you a bit about the timelines and the segment list and the tutorial software that you can find. So here you have heard already a lot talking about strain, but I put here a reminder just in case. So the strain is, of course, the main content of the data that you will find online. And this data will be provided in three formats. HDF5, that is the most easily readable with Python, MATLAB, C, IDL. And I will show you a few examples taken from the LOSC website that use this format, but there are other formats. So GWF is called frame format, is actually a very old style format used internally in the collaboration. And you can, only for the event, not for the bulk data, you also find text files, so basically 2 columns with the time and the strain. So I put here for an example of a screenshot that you can have if you open one of these data with a viewer. For example, if you use HDF view, it gives you a nice quick view of what is inside the data. As Jess already said this morning, you can see that there are 3 keys in the file: meta, quality, and strain. So you have already heard, so meta contains the metadata, so the description of the data. Quality contains the data quality and the injection information, sampled always at 1 Hz, so 1 bit per second. And then strain contains the actual data. So here you find a simple code, just to show how simple it is. This is the first part of the code that you can find also at the link in the upper part of the slide. Okay, you see that there are some import, then you open the file, and with this for loop you can list the 3 keys of the meta, quality, and strain. So if you execute this, the output will be the 3 name of the folder, let's say. And then you can very quickly, for example, print the strain for the first 10,000 seconds. For the 10,000 samples. That in this case, this file was sampled of 4 kHz, so it's 2 seconds of data. And okay, as you can see, you can easily find in the metadata the start, then duration, and then okay, you can plot the time and the strain for this file. So what about the available data set? The link to the website is very simple, so loscligo.ligo.org. And you can find 2 different types of data release. So you can find the event, so the gravitational wave data surrounding specific discovery, but also the whole observation run. So the data that the event that you find are listed in this table. The green refer to O1 and the pink, reddish more or less, refer to O2. As you can see, the last two events contain not only LIGO but also Virgo data. And while the whole observation runs at the moment that you can find, so S5, S6, and O1 are LIGO only data. And we are working for the release of O2 now. This plot shows basically what I already told, but more nicely view. So you see the evolution in time and the three detectors. So as I was saying, so these are the S5, 6, and O1, and then O2 that still has to be released. And this line here represents the events that I was mentioning. And the color code is show you how the BNS range has improved with time. And now, in this moment, we are not taking that because we are going through another period where we will improve again our result, hopefully. So now I will show you some videos that are basically taken from my screen to show you more easily what you find in the website. So let's see if I can make these things start. So, okay, I highlight in the upper part here the website, even if probably you can see. If you click on events, this page appears with all the events I was mentioning before. If you click on one of these events, you will see in the upper part the description of the important thing to know about the event itself, so about the data. Then this event specifically was an event of O2, so you will have the clean data. So then, as was said before, for O2 we had this post-processing procedure that remove additional noise. So here you see the clean data, and you find it for both 4 kHz and 6 kHz. And in this case, it was chosen to deliver both a small period of time of 32 seconds and another files with 4,000 seconds, more or less, for the three detectors. And again, you see in the table the three types of file I was mentioning before. So, but if you want, you can also have the data just the one calibrated, so without the cleaning, because these data were used for the low latency analysis. And that's all, I think, yes. So in this other video, you see instead what happens if you click on bulk data. So here you find the release of the observation run. As you see, you have data, documents, and timeline for each run. This is what happens if you click on O1. You can choose the detector, so N for Livingstone. You can choose the start and end time that you want to look at. And here you have a conversion in GPS time, because you need the GPS time to do the query on the database. And, okay, here I was playing a bit with the numbers, okay. And then once you have chosen your period of time, you will see. So you will see the segments that you can, the file that you can download in two formats that I was saying. And you see also the percentage of time for this specific file where the detector was on, and you can download the file. You have also another way, as I showed you before. You have also the timeline that is that make you visualize when the detector was on along the period. Every time you click, you zoom over factor 2 on this viewer, and when you are satisfied of clicking and zooming, okay, you can download the data, and you will arrive again to the similar page as before. So, as you have guessed already, the detector is a complex detector, which means that it's not 100% active all the time. And even if, so there are moments where the data is not in science mode, and there are moments where even if it's running, the quality is not sufficient. Just explained all the typical of the type of category of data quality that you can require. So you have to work with the segments. And for example, in this screenshot of the timeline that I was showing before, you see 6 segments. So this tool is very powerful to make you see and download the segment. And here, okay, if you click on timelines and you make a query form, for example, selecting O1, again, you can choose the GPS start and stop, but here you have to go to the converter to, if you want to a specific time, and here I was playing with a date to get a specific time, and then I copied and pasted in the other page. And okay, you say the duration, then you can specify which of the category of that you want, so CBC category 1, bars 2, data type of detector. And if you click on the link in the lower part of the page, you will get again to the timeline. And you can see at the end, so the GPS start, stop, the duration of the segment that fulfill your required criteria. So, okay, this method are make you visualize and download this information, but then if you need some tool to write code to read this segment, and on the LOSC page you have a lot of examples and tutorials on how to do that, and a very useful tool is using this read LIGO.py API that if you download it and import in your Python file, then allow you to load the data and extract the strain time series, GPS time series, and the dictionary. You probably don't see this color, but okay, it's dictionary of the data quality flags. And so you need to specify the file and interferometer. Then with this other method, get segments, you can download the list of GPS of the segments, so the list of starting and stop of the GPS. Again, for the GPS time, the detector, and you can choose one flag. And this is an example of a simple program that get this segment, and this printing here will give you this, so you will see all the segment. And then, for example, this loop basically looping on all these segments plot the first 10,000 sample for each. And you can find this code in here. So as you can see, this code does not use any of our tools that you will anyway study in the next day. These are more intended as educational. This is our tutorial page. You will find in the upper part of the page some notebook, and in the lower part this other link to other page that show you again how to read the data, how the data are structured and how to read them. And again here I have another video to show you this page. Okay, it's the same as the screenshot I was showing before. And then if you click on one of the events, this is the This is the tutorial that show you how to find the signal in the open data. It's for educational purposes, so it does not use any of our internal packages. So here, okay, I scrolled along the page and I will show you just the important feature of the tutorial. So, okay, this is the initial part where you read the event, the information of the event, and then the tutorial show you how to plot again the strain, how to plot the amplitude spectral density, and okay, also how to calculate the BNS range I was mentioning before, how to whiten the data, how to make spectrograms. Okay, this is an example of spectrograms, and you will see a lot of them nicely produced with our tool, but this does not use any of the specific tools of the collaboration. Then also this also have the template. You will hear about that in the next days. Okay, and I think there was. Okay, this is a match filtering. Okay, I think that's all. Okay, so then in this other page you find the software. Some of these will be discussed here in the afternoons. But you can find here all the links, and that's all. If you have a question.